Let's begin with the 5-minute check here. I would like you to graph the lines on the coordinate plane, and if you could do these all in one color and do these two in a different color, that would help us with the second step here. So remember, we're graphing with slope-intercept form. That'll be the quickest way to graph that. So I'd like you to go ahead and graph these 5 problems here, and then press play and see how you did just on graphing those. This is an old skill, so you should be familiar with this. Shouldn't be difficult. So hopefully you have tried these already. If we graph this one, y equals 2x plus 4. Remember, when we graph with slope-intercept form, we start from the back. So the y-intercept is 1, 2, 3, 4. The slope is 2 over 1, so we go up 2 and over 1, up 2 and over 1. And we can do the opposite, down 2, back, down 2, back, down and back, down and back, down and back, down and back. And that will give us a straight line, relatively straight line. Sorry. Okay, now, that's better. What about the second one, y equals 2x minus 3? Again, start from the y-intercept first, negative 1, 2, 3. The slope is 2 over 1, so we up 2 over 1, up and over, up and over, up and over, and over, down and back, down and back, down and back. So, here's our second line. And our third line is not in slope-intercept form, so we need to put this in slope-intercept form first. Add the 4x to both sides. 2y equals 4x plus 4. We still need to get y alone, so divide everything by 2, and we get y equals 2x plus 2. So this time we start at 2. We go up 2 and over 1, up and over, up and over, down and back, down and back, down and back, down and back. And here is our third line. Now, go ahead and graph 4 and 5 if you haven't done those yet, and we'd like to do those in a different color. So get a different color if you don't have a different color. All right, number 4 is in slope-intercept form, so you can graph that. 1, 2, 3, 4, 5. And your slope is negative 1 over 2. Negative 1 over 2, negative 1 over 2, negative 1 over 2. Okay. And number 5 is not in slope-intercept form, so you need to solve that for y by dividing everything by 2. So we get y equals negative, this is an imaginary 1 here, so negative 1/2 x minus 2. So this time we go down 2, and our slope is negative 1/2, negative 1 over 2, negative 1 over 2, negative 1 over 2. And when we graph that, let's do a couple more here. So, what do we notice about the first 3 lines? What do they all have in common? That's these 3 right here, these 3 pencil ones. They are all parallel, all right? So how could we know by these 3 equations that these might be parallel without graphing them? So what do these 3 equations have in common? So this one, and this one. What is the same in all 3? The slope is the same, 2x, 2x, 2x. So this helps us with our discussion about parallel lines. Parallel lines have exactly the same slope. Have exactly the same slope. Okay? What about 4 and 5? If we look at 4 and 5, compare them to each other, they are also parallel to each other. So let's look at their slopes. Negative 1/2 and negative 1/2. So these both have exactly the same slope, -1/2, and they're also parallel. But what is the relationship between one of these lines with one of these lines? They will be perpendicular, all right? Perpendicular, remember, means that they meet at right angles. So this line going this way is perpendicular to each of these three lines. This one is also perpendicular to each of these three lines. So what do we notice about these equations versus these equations? What do they have that we could compare? The slopes in all three of these are 2. What are the slopes in these two? -1/2. So equations of lines that have a slope of 2 end up being perpendicular to equations of lines that have a slope of -1/2. And that helps us define perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. For example, 2 and -1/2. Okay, reciprocal, remember, what's the reciprocal of 3/4? The reciprocal of 3/4 is 4/3. But we're talking about the negative, or some people would say the opposite reciprocal. So they're reciprocals of each other, but one of them has to have an opposite sign. I use the idea of flip it and switch it. So we flip it upside down and we switch the sign of it, and that will make it perpendicular. So let's try some examples here. It says find the slope of the line that is parallel to the graph of each line. So parallel. Now if we want to find the slope of the line that's parallel to each of these, we need to figure out what the slope of this line is. So if we look at this equation, the slope of this line is 1/3. Now parallel has a symbol. Parallel symbol looks like this. All right, and the perpendicular symbol, so the parallel is a miniature set of parallel lines. Perpendicular, they're perpendicular lines, but they don't go intersect all the way or look like a plus sign. So it's like an upside down T. So if the slope of this line is 1/3, the slope of its parallel line has to be exactly the same. So the parallel slope is also 1/3. Why don't you try number 2 and number 3 on your own? These should be pretty easy. And come back and check it. So if y equals -2x minus 1 is our equation, then the slope of this line is -2. Notice the slope never includes the x. The slope is the number in front of the x. So the parallel slope is going to be exactly the same, -2. And what about number 3? Well, we can't do it right away. We have to get this in slope-intercept form first. So we divide everything by 2, and we get y equals, now remember, this is understood to be 1x. So this is 1/2 x minus 4 divided by 2, which is 2. So the slope of this line is 1/2, and the parallel slope is also 1/2. Parallel lines have exactly the same slope. So the slope of this line and the parallel line, or any parallel line to it, would have to have that same slope. Similarly, if you want to find the slope of the line that is perpendicular to the graph of each line, first identify what the slope is, which in this case is -3/8. And then your perpendicular slope would be flip it and switch it. So flip it upside down, so it's now 8/3. Since this one was negative, then our perpendicular slope would be positive. And you don't have to write the positive there, of course. So why don't you try 5 and 6 on your own? Identify what the slope is once you've done some work, and then identify what the perpendicular slope would be. Go ahead and push pause here and try those on your own. So in number 5, we have to get it in slope-intercept form first, so we divide everything by 3, and we get y equals negative 2/3 x plus 1/3. So what is the slope of this line? The slope of this line is negative 2/3. And the perpendicular slope